Okay, welcome back. Today we're going to go over section 2.1, change in arithmetic and geometric sequences. So the first thing we need to be able to identify is what kind of sequence we have. We have either arithmetic or geometric. So for arithmetic sequences, we need to know what our formula is. So our general formula for arithmetic sequences is a sub n is equal to a sub k plus our common difference d times n minus k, where k is whatever term we are basing our formula off of. And similarly, for geometric sequences, we have g sub n is equal to g sub k times our common ratio to the power of n minus k. So these are going to be our two formulas that we use for throughout this section. And in the directions, we're given that we use the initial value k is equal to 0. So that means that, remember, all of our sequences are starting with a or g. It doesn't really matter what letter we use, but our first term, second term, third term, fourth. So if we have a geometric sequence, this would be g sub 1, g sub 2, g sub 3, g sub 4. And since we're using k is equal to 0, that means that we're using the 0th term, so what the term before this would be. And so if we use the 0th term, for these two formulas, what that's going to look like is for the arithmetic sequences, we're going to have a sub n is equal to a sub 0 plus d times n minus 0. Well, n minus 0 is just n, so d times n. And for the geometric sequences, we have g sub n is equal to g sub 0 times r to the power of n minus 0, which is just n. So these are kind of our two simplified formulas when we're using k is equal to 0. So really, I recommend you only memorizing the two bottom ones that I've written here, because these are the general formulas where we can base our sequence off of any term. And where k is equal to 0, really, these are just two special cases of these two formulas. So if you'd like to reduce the amount of memorization that you have to do, memorize these two and understand that the two above those are just special cases. So with that in mind, let's look at whether we have a geometric or arithmetic sequence here. And so remember, with an arithmetic sequence, we're adding the same value for each term. So if this were arithmetic, 9 plus what gives us 27? Well, that'd be 18. But 27 plus 18 is not 81. So we know that this is not an arithmetic sequence. However, are we multiplying by some common number? Well, 9 times 3 is 27, and 27 times 3 is 81, and 81 times 3 is 243. So we definitely have a geometric sequence, because every time we are multiplying by 3 to get to the next term. So how do we set this up? Well, if we want to let k equal 0, we need to figure out what our 0th term is in this sequence. So we kind of have to work backwards. If we know that we're multiplying by 3 to get to the next term, then to work backwards, we need to divide by 3. And so we can take 9, divide it by 3, and that's going to give us 3, because 9 divided by 3 is 3. So we have a geometric sequence, and using the formula g sub n is equal to g sub 0 times our common ratio to the power of n. Well, g sub 0, remember, is equal to this this term before the first one. These sequences are always starting at g or a sub 1. So g sub 0 is going to be this 3. And our common ratio is that we're multiplying by 3 every time. So g sub 0 is equal to 3. Our ratio happens to also be 3. And now, just plugging in all of this information, we have g sub 0, which is 3 times our common ratio of 3, and then to the power of n. And so we can leave it like this, and g sub n is equal to that, and this is our final answer. Okay, so what about the second one? For the second one, we need to know, is this arithmetic or geometric? So let's just check with arithmetic, because I think that's usually the easiest one to identify. So we start at -4, and then we get to -1. What do we have to do that? We have to add 3. And then -1 plus 3 is 2. 2 plus 3 is 5. We don't even need to check if this is geometric, because every single time we are adding 3. And a sequence will only be arithmetic or geometric. It can't be both. Now, it can be neither, which we'll see in the next section, but at least for this assignment, it's either going to be arithmetic or geometric, and regardless of the assignment, it'll never be both. So now we know we want to use the formula a sub n is equal to a sub 0 plus d times n. So first, let's figure out what a sub 0 is. So, similar to the last problem, if we want to figure out the term before, we have to work backwards. So instead of adding 3 to go forward, we're going to subtract 3 to go backwards. And so a sub 0 is going to be -7, because -4 minus 3 is -7. Then, what is our common difference? Our common difference is that we're adding 3 every time. So d is equal to positive 3. And now, plugging in that information, we get a sub 0, which is -7, plus 3, our common difference, times n. And so a sub n is equal to this. And this is our formula. All right, and for number 3, we want to figure out, do we have an arithmetic or a geometric sequence? So first, let's start with arithmetic. Let's see, to go from -1 to -4, we have to subtract 3, and then, okay, so -4 minus 3 is not -16. So by process of elimination, we probably have a geometric sequence here. However, again, that's only because this is this assignment where it has to be either geometric or arithmetic. You should still definitely check just to verify that a sequence is actually, geometric, or it could, because it could be something else. Just again, this assignment doesn't happen to have any other type of sequence. But -1 times, let's see, that would be 4 gives us -4. And sure enough, -4 times 4 gives us -16. -16 times 4 gives us -64, and so on and so forth. So let's see, we have times 4, times 4, times 4. And so that means that our common ratio is 4, because that's what we're multiplying by every time. And now we need to figure out what the 0th term is. So if we're multiplying by 4 every time to go forward, then in order to work backwards, we need to do the inverse operation, which is division. So dividing -1 by 4, that means that g sub 0 is going to be -1 divided by 4, so -1/4 is going to be the 0th term. And so, again, using that g sub n is equal to g sub 0 times r to the power of n, since we know what g sub 0 is and we know what r is, then we can just piece this together, and we have g sub n is equal to -1/4 times 4 to the power of n. And this is your final answer. This is our formula that gives every term subsequent to each of these. So, something to point out with the geometric sequences, so we have 2 of them here, right? If you have determined that, or maybe you haven't determined that it's a geometric sequence, something that you can do to figure out the ratio every time is that the ratio is given by some term, I'll call it g sub m, any of your terms divided by the term previous to it. So for example, if I take 81 and I divide it by the term before it, 27, 81 divided by 27 is equal to 3. And that was our ratio. But I could also have done 27 divided by 9, and 27 divided by 9 is also 3. What about over here? What if I do negative 16 divided by negative 4? So take a term and then divide by the term previous. Well, that gives us 4. But I could have also done negative 4 divided by negative 1. And that gives us positive 4. So we can always figure out our ratio for a geometric sequence by taking a term and dividing it by the one before it. Yeah, that's going to come in handy. That's a neat little, trick to have up our sleeves here. So let's look at the next set of problems. So let's look at number 4. So it's the same instructions as before. We're going to use that a sub n is given by a sub 0 plus d times n, and we're going to use that g sub n is equal to g sub 0 times the common ratio to the power of n. So let's see. Or do we have arithmetic or geometric sequences? Well, 10 minus 5 is 5, but 5 minus 5 is not 5 over 2. So, not arithmetic. What about geometric? Okay, well, 10 divided by 2 gives us 5, and then 5 divided by 2 gives us 5 over 2. And then 5 over 2 divided by 2, sure enough, is 5 over 4. And so, let's see, we know that our ratio is dividing by 2. Well, dividing by 2 isn't, it's not going to be r equals 2. Remember, we can always determine this by one term divided by the previous one, so 5 over 2. Oh, sorry, 5 over 10. And 5 over 10 is 1/2. So you have to be careful about this. Because we're always framing the ratio as what we're multiplying by to get to the next term. So, dividing by 2 is the same thing as multiplying by 1/2. So, just be careful with that. But our ratio is 1/2. And so, how do we get to the next, or how do we figure out what g sub 0 is? Well, remember, if we are dividing by 2, then we do the inverse operation to work backwards. So dividing by 2 goes forward, so multiplying by 2 will go backwards. So if we have 10 and we multiply it by 2, that gives us 20. So g sub 0 is equal to 20. Therefore, if we have g sub n is equal to g sub 0, which we've determined is 20, and then times our common ratio, I highly recommend putting this in parentheses. Anytime you have a fraction, at least. Our common ratio to the power of n. The reason we want, we box that real quick because that is our final answer. The reason we want to put this in parentheses is that if we have 1 over 2 to the power of n, like this, it is a little bit ambiguous. So if I tell you that we have 1/2 to the power of n, that's fine as a verbal description, but this is when it's just written, it's kind of ambiguous because it looks like we have 1 raised to the power of n divided by 2. And that is not going to be the same thing as 1/2 all to the power of n. So we just have to be careful about that. So I'm going to write a little note here that 1 divided by 2 to the power of n is not the same thing as 1 over 2 to the power of n. So anytime you have a fraction, just be careful with that. Put that in parentheses. That way we know that this n it distributes to that 2 there. So just be mindful of that. I guess in particular, the property that I'm thinking of here is that a divided by b to the power of n is equal to a to the n divided by b to the power of n. So you can see where that would be a problem, because what we should have is that we have 1 to the power of n over 2 to the power of n by this property here. So 1 to the power of n divided by 2, it's not going to be the same thing. Anyways, enough about that. Let's move on to number 5. Let's see if we have an arithmetic or a geometric sequence here. So -5, let's check if we have arithmetic. So -5, we are subtracting 4 to get to -9, subtracting 4, subtracting 4. This checks out as an arithmetic sequence, and we're subtracting 4 every time. So our common difference is -4, and then we want to figure out what the 0th term is. So we'll work backwards, and we add 4 to work backwards. So this is going to be a -1, because again, -1 minus 4, if we're working forwards, is -5. So a sub 0 is -1. And now piecing this together, we have a sub n is equal to -1 minus 4, because we're adding, I guess it's plus t. In fact, I'll write that step explicitly just to make sure that everyone's on the same page of what's happening here. But we have plus -4 times n. And so it's because of this double sign here, we're adding a negative number. That's why this switches out to a -1 minus 4n. So just want to make sure we're very clear on what happened there. But basically, you're just going to replace that d with the -4, and the sign is just going to match whatever you have for d. Okay. Let's see about number 6. Okay. So, let's see. Do we have arithmetic or geometric? Well, if we have an arithmetic sequence, if we have 4/3 and we minus 1/3, that would be 4/3 minus 1/3. I'll write that up here. 4/3 minus 1/3. That should give us 3/3, which is equal to 1. Okay, and so surely, if this is arithmetic, I should be able to subtract 1/3 again from 1 to get 3/4. However, 1 minus 1/3 is equal to 2/3, which is not equal to 3/4. So this is not arithmetic. So it's geometric. So what is our common ratio? Well, remember, we could always take a term and divide it by the one previous to it. So it doesn't matter which 2 terms we pick, but if we're dividing by a term, the easiest thing we can ever divide by is 1, because anything divided by 1 is itself. So our ratio can be given as 3/4 divided by 1, which is just 3/4. And so that is our ratio. Now, if you're skeptical that that is our ratio for a geometric sequence, surely if we're really multiplying by allegedly 3/4 every time, then this should work for every single time that we multiply. Well, 4/3 times 3/4 is 12/12, which is 1. So 4/3 times 3/4 is indeed 1. And then 1 times 3/4 is 3/4. So that checks out. And even if I do 3/4 times 3/4, remember, if we're multiplying fractions, we have 3 times 3, which is 9, and then 4 times 4, which is 16. So clearly, we've shown here that 3/4 really is our ratio here. And what about the previous term? So if we have to figure out what the previous term is, we have 4/3, and working backwards, we have to divide by 3/4. So, let's see. Let's take 4 over 3. Running out of room here. A lot going on. We're going to take 4 over 3, and we should be able to divide by whatever our ratio is. Divided by... Sorry, yeah, I said our ratio. Our ratio is 3/4. So if I take 4 over 3 and divide it by 3 over 4, remember if you have fractions, you can switch this to multiplication by flipping whatever this fraction is. So we're going to change this into 4 over 3 times 4 over 3. So if you have two fractions that you're dividing, you keep the first fraction and change division into multiplication, and then just flip this fraction. So you take the reciprocal, 3 over 4, reciprocal of that is 4 over 3. And so that means you have 4 times 4, which is 16, and then 3 times 3 is 9. So this is, sorry, we're using G. G sub 0 is 16 over 9. And remember, our ratio was 3 over 4. So, a lot going on in this box. However, our formula is going to be equal to G sub 0, which is 16 over 9, and then times our common ratio of 3 over 4, put that in parentheses, to the power of n. Sorry that got a little bit cramped in there, but that is our formula for this one. Okay, now find an equation that gives the nth term of each sequence, and instead of the initial value, use the kth term of the sequence. So remember, this means that we have to use the general formula for each of our sequences. So first, we have to figure out what kind of sequence do we have here. Well, let's see. 75 minus 60 is 15, but 15 minus 60 is not 3. So this is not arithmetic. What about geometric? So we can either say that, or recognize that this is dividing by 5 every time, because 75 divided by 5 is 15, 15 divided by 5 is 3. Or if we can't recognize that, maybe we're in a rush or our brains are not feeling very functional because we've been on a 9-day break, what we can do is always divide one term. I'm going to choose you can choose any terms, but 15 divided by 75 will work, and that simplifies to 1/5. I could have made this easier on myself by choosing 3 over 15, which would also be 1/5, but it doesn't really matter. And then we want k to be equal to 2. So our formula is going to transform, since we're using a geometric sequence. Remember, the general formula is G sub n is equal to G sub k times our common ratio to the power of n minus k. Well, if we're using k is equal to 2, that means that we have G sub n is equal to G sub 2 r to the power of n minus 2. Okay, and remember, this formula right here is determined by this k is equal to 2. So we just swapped out k for 2 in this formula. That's the only thing we did. And so if we know that r is equal to 1/5, now we have to figure out what G sub 2 is. But G sub 2, remember, all of these sequences start at 1. So this is G sub 1. G sub 2 is 15. So that means that G sub n is equal to 15 to the power of, times r, which is 1/5. I'm going to put that in parentheses. Oop, ran out of room. But to the power of n minus 2. We didn't even have to figure out what G sub 2 is because it was already given in our sequence. Whereas before, if we were trying to find G sub 0, that's not given in our sequence. We would have to multiply 75 by 5 to get to to g sub 0, but we don't, since we're basing our formula off of the second term, we don't have to do anything. It's already given in our sequence. I realize that 15 looks a little not like a 15, so there we go. But yeah, what about this next one? Let's see, are we adding, or are we, do we have arithmetic or geometric? Well, let's see if we have arithmetic. So 44, let's see, how do we get to 36? We subtract 12. No, we do not subtract 12. Jeez, okay, see, I've also been on break and my brain hasn't been thinking about math. We subtract 8 to get from 44 to 36, and then 36 minus 8 is 28, 28 minus 8 is 20. So this checks out. We are subtracting 8 every time. So our common difference is negative 8. And we know that k is equal to 4. So we already know that we're going to use the fourth term, a sub 1, a sub 2, a sub 3, a sub 4. We know that a sub 4 is equal to 20. Nothing to really, calculate there. Now, if we want to, and since we're using arithmetic, our formula for that, or the general formula is going to be a sub n is equal to a sub k plus d times n minus k. Well, remember, since we are letting k equal 4, the real formula that we're going to use here is a sub n is equal to a sub 4 plus d times n minus 4. Well, we know that d is negative 8. We know that a sub 4 is 20. So a sub n is equal to 20 minus 4 times n minus 4. And that's all we have for that. Okay, what about this next one? Let's see. Negative 10 minus 90 is negative 100. Minus 90 is definitely not negative 1000. Okay. Negative 10 times 10 is negative 100. Times 10 is negative 1000? Yes. Times 10 is negative 10,000? Yes. So our common ratio here is times 10. We could also deduce that by doing negative 100 divided by negative 10, which is also 10. So pick any two terms, divide 1 by the previous term, and that'll also give you your ratio. But since our ratio is 10, and we want to use the third term, because k is equal to 3, we know that this is geometric, so g sub n is going to be equal to g sub 3 times r to the power of n minus 3. And plugging in this information, we have g sub n is equal to g sub 3, which is negative 1000, times r, I'll put that in parentheses, which is negative 10 to the power of n minus 3. And that will be our formula. Alright, what about this next one? Do we have arithmetic? I don't know. Let's see. Well, 11 plus 11 is 22. Plus 11 is 33. Plus 11 is 44. Sweet. We're adding 11 every time. So our common difference is positive 11. And what about the second term? What do we have here? Well, second term is going to be 22. So a sub 2 is 22. Our general formula is going to be a sub n is equal to a sub 2 plus d times n minus 2. And now just piecing this together, we have a sub n is equal to 22 plus 11 times n minus 2. And there we go. Okay, what about this next one? Do we have arithmetic? Let's see. Well, 9 over 4 plus something is 3 over 2. Okay. Well, I'm going to write this on separate paper because I will definitely run out of room if I do this on this. So let's look at that for a second. 9 over 4 plus something is equal to 3 over 2. Well, let's just... almost like we have a symbol for an unknown quantity, x. Let's call it unknown quantity x. Let's see, if we wanted to solve for x, let's see, if we subtract 9 over 4 from both sides of this, x is equal to 3 over 2 minus 9 over 4. Then we just need to combine these two fractions. To get a common denominator, we're going to multiply both top and bottom of this fraction by 2. That gives us 6 over 4 minus 9 over 4. And 6 minus 9 is negative 3. And negative 3/4. So, 9 over 4 minus 3 over 4 is equal to 3 over 2. But is 3 over 2 minus 3 over 4 equal to 1? Well, we can, if we do 3 over 2, if we get that to a common denominator of 4, that would be 6 over 4 minus 3 over 4. 6 minus 3 is 3 over 4, which is not equal to 1. So, not arithmetic. So, this has to be geometric then. Let's see. Instead of breaking our brains here, let's use the fact that we have a 1 in the sequence. And let's take one term and divide it by the previous one. Well, dividing by 1 is always going to be nice. So 2/3 divided by 1. So our ratio is given by 2/3 divided by 1. Anything divided by 1 is itself. Our ratio is 2/3. And let's see if that checks out. Because surely, if I do 9 over 4 times 2/3, that should give us 3 over 2. And we can verify that by doing 9 over 4 times 2 over 3. Well, 9 times 2 is 18 divided by 12. And 18 over 12, we can divide both of those numbers by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. So that should be our next term in the sequence. And sure enough, that's what we have, 3 over 2. So we know that our ratio is in fact 2/3. And now we're wanting to use that k is equal to 3. Well, let's see, g sub 3 is going to be equal to this 1 here. So g sub 3 is equal to 1. And now, our general formula is going to be given by g of n is equal to g sub 3 times r to the power of n minus 3. Well, in this case, that's going to be g sub 3, which is just 1. So we don't need that. I'll write it to be explicit here. But 1 times our ratio of 2 over 3 to the power of n minus 3. And of course, we can clean that up a little bit. We can just say that, I'm going to write this up here, g sub n is equal to just 2/3 to the power of n minus 3. So, we really don't need that 1 there, but it's good to have it. I guess if you're trying to be explicit about what your term is, but you really don't need it. I would definitely prefer this answer. Okay, what about number 12? So, do we have arithmetic or geometric? Well, I can look at these two terms here. If it was arithmetic, surely we'd be adding by 2 if we got from 1 to 3. However, working backwards, 1 minus 2 is definitely not 1/3, so it's not arithmetic. So what about geometric? Okay, well, we can do 3 divided by 1. Our ratio is equal to 3 divided by 1. That's equal to 3. And does that check out? Well, 1 divided by 9 times 3, that's equal to 3 over 9, which is 1/3. And so, yeah, clearly we have to be multiplying by 3 every time, because then 1/3 times 3, we should definitely recognize that that's equal to 1. 1 times 3 is 3. So our ratio is definitely 3. And our second term is that 1/3. So our formula is going to be g sub n is equal to g sub 2 times our ratio to the power of n minus 2. And that means that we have g sub n is equal to g sub 2, which is 1/3. And then times our common ratio of 3 to the power of n minus 2. And that is our formula for number 12. Okay, so what about 13 through 16? So we want to find the nth term of each sequence. So first we need to find the equation for each sequence before we can find the nth term. So far in all of these examples, we have found the equation. And what's really nice about this is the reason we're motivated in finding the equation is what if we wanted to find, say, the 87th term of this sequence? Well, you can count. You can do, let's check if this is arithmetic. 105 minus 10 is 95, minus 10 is 85, minus 10 is 75. Definitely arithmetic. So we could do minus 10 87 times, but that's going to be pretty inefficient. Don't recommend doing that. So if we figure out a formula, we can plug in 87 into our formula, just like a function, and it'll crank out whatever the 87th term is, or whatever other term we want to figure out. So first, let's find a formula. We've already established that our common difference is negative 10 for this one, and we can choose whatever value we want for k. I'll choose k is equal to 1, because why not? So if k is equal to 1, then our first term is going to be 105. So a sub n is equal to a sub 1 plus our common difference times n minus 1. So if we're letting k equal 1, this is going to be our formula. And then a sub 1 is just 105. And then our common difference is minus 10. And then times n minus 1. So this is our formula here. But now we want to figure out what the 87th term is. So how do we do that? We plug in 87 into this. So a sub 87 is going to be 105 minus 10 times 87 minus 1. That's 105 minus 10 times 86. 105 minus 860. And my brain's not big enough to do that on the fly. But that is negative 755. So a sub 87 is equal to negative 755. And there we go. So why would we care to do this? Because we could arrive at the same conclusion if we subtracted 10, starting at 105. If we subtracted 10 another 86 times, we'd get there. But if we have a formula, we can figure out the next term fairly easily. So what about number 14? First, let's figure out, is this arithmetic or geometric? Well, 1 over 6 times 6 is going to be 1, but is 1 times 6 11 over 6? No. So we know that this can't be geometric. Is this arithmetic? And the reason I checked for geometric is because it looked kind of like the other geometric sequences we'd had. This was a geometric when we saw the 1. This one was also geometric and it had a 1. This one was geometric when it had a 1. But clearly, this one is not geometric, even though we saw the 1. So they're trying to trick you here. And again, that's because 1/6 times 6 is 1, but 1 times 6 is not 11 over 6. So this has to be arithmetic. Well, how can we show that that's arithmetic? So first, let's see, we started with 1 over 6. We have 1, and then 11 over 6, and then 8 over 3, ... let's see if we can write all of these with the common denominator. Well, common denominator between all of these is 6. So 1 over 6 is good. 1 as a number with a denominator of 6 is going to be 6 over 6. And then we have 11 over 6. That's fine. And then 8 over 3, we can change that with the denominator of 6 by multiplying both top and bottom by 2. That's going to be 16 over 6. And now it may be more clear what our common difference is, because look, we have a 1, a 6, 11, 16. So, since these all have a common denominator of 6, we are adding 5 over 6 every time to find the next term. So, our common difference here is 5 over 6. And now we want to figure out what is the 34th term. So, a sub n is equal to, let's use the second term. That one might be nice. We have a sub n, here, let me write out the explicit formula first. A sub 2 plus our difference times n minus 2. A sub 2 is going to be this 1. So 1 plus our common difference of 5 over 6 times n minus 2. So this is our formula. Now we just need to plug in 34 into this. Well, a sub 34 is equal to 1 plus 5 over 6 times 34 minus 2. Bring this party up here. A sub 34 is equal to 1 plus 5/6 of 32. And so when you throw this into your calculator, this is going to be a sub 34 is equal to 83 divided by 3, or you can say 27.6 repeating. Either one of those answers will be acceptable. Let's look at number 15. All right. So for number 15, what is the 52nd term? Let's see if we're doing arithmetic first. Okay, so negative 86 plus 6 is negative 80, plus 6 is negative 74, plus 6. Okay, cool. So our common difference is that we're adding 6 every time. Now, let's see what we have. For the 52nd term, let's use a sub 0. So let's set k equal to 0. First, we have to figure out what is a sub 0 equal to. Okay, so if we're adding 6 every time to get to the next term, then we need to subtract 6 to get to the previous term. So negative 86 minus 6 is going to be negative 92. So that's the nice thing about the general formula is you can choose whatever term you want to figure out your formula. All of the formulas are going to be equivalent to one another. So if we were letting k equals 0, we're using the 0th term as the basis of our formula, then we have a sub 0 plus d times n. A sub 0 is negative 92, and our common difference is 6, and then times n. So this is our general formula, and now we want to figure out what the 52nd term is. So a sub 52 is going to be negative 92 plus 6 times 52. And if you throw that into your calculator, that is going to be 220. So a sub 52 is equal to 520. Okay, what about number 16? We want to figure out the 120th term. Okay, let's see if we have an arithmetic sequence. Negative 21 minus 4 is negative 25. Minus 4 is negative 29. Minus 4 is negative 33. Our common difference is negative 4. All right, and let's use the third term. And again, that is completely arbitrary which term you use. I'm just trying to show that it doesn't matter. So a sub 3 is negative 29. And so our general formula is going to be given by a sub n is equal to a sub 3 plus d times n minus 3. A sub 3 is negative 29. So negative 29 minus 4 times n minus 3. And so if this is our general formula, let's figure out what a sub 120 is. A sub 120 is going to be given by negative 29 minus 4 times 120 minus 3. Ran out of room there a little bit. But if you throw all of that into your calculator, this will simplify to negative 497. And you can show this for yourself. You can pick any term you want, and you will get all of the same answers here. So it doesn't matter what term you base your formula off of. Okay, so let's look at the test prep, our favorite section. So, which of the following equations could represent the sequence, blah, blah, blah. Okay, well, first, let's just observe all of the answer choices are in the form of an arithmetic sequence, and we can verify that by doing 10 minus 8 is 2, minus 8 is negative 6, minus 8. So we can definitely deduce that d is equal to minus 8. And let's figure out what a sub 0 is. A sub 0, if we're subtracting 8 to get to the next term, we need to add 8 to figure out what a sub 0 is. It's going to be 18. So, our general formula, one of the simplest one that we can write, is where we have a sub 0 plus d times n. Well, in this case, that's just going to be a sub 0 is 18 minus 8n. So, let's see if any of these, how many of them, because it's multiple ones that it could be, are equivalent to 18 minus 8n. Well, just observing, choice 4 here is 18 minus 8n, exactly. So that checks out. And so we should be able to see that, well, 18 minus 8n is not equal to 10 minus 8n. So can't be that one. And then we have this one over here, negative 8 plus 10n. This is not equivalent to number 4 either. So it can't be that. But what about number 1 here? Well, we can always simplify that. If we take 10 minus 8 times n minus 1, this is going to be equal to 10 minus 8n plus 8, and then 10 plus 8 is 18, minus 8n. So 18 minus 8n, 18 minus 8n. This one checks out. What about this one over here? For number 3, we have negative 8 plus 10 times n minus 1. Simplifying that, we have negative 8 plus 10n, and then minus 10. And simplifying that, we have negative 18 plus 10n. And so that one checks out as well. And what about this last one here? We have 2 minus 8 times n minus, plus 2. Let's simplify that. We have 2 minus 8n minus 16. This is equal to negative 14 minus 8n. And that is not equal to 18 minus 8n. So that one does not check out. So 3 of these formulas are actually all equivalent. It just depends on what term you use to base your formula off of, but they're all the same thing. They'll produce the same sequence. But yeah. Okay, what about number 18? Which of the following equations could represent this sequence? Well, what I'm going to do is figure out what is the 0th term first. So what kind of sequence do we have? Well, one, we can figure out, just looking at the answer choices, it's probably geometric because these are all in the form of a geometric sequence. But let's verify that for ourselves. First, let's figure out what the 0th term is. Well, I guess if we want to figure that out, we need what the common ratio is first. So we can take, for example, 8 divided by 2. Common ratio should be given by 8 divided by 2, which is 4. So common ratio is 4. Okay. Now, what is the 0th term? Well, the 0th term is going to be 1/2 divided by 4, whatever our ratio is. So, let's see, 1/2 divided by 4, that's going to be 1 over 2 times 1 over 4, which is 1 over 8. And sure enough, 1/8 times 4 is 1/2. So, our general formula should be in the form of 1/8 times our ratio of 4 power of n. So all of our formulas should be able to simplify into this. So just ruling out, we can already rule out, I guess, answer choices 1 and 4, because, well, they have a ratio of 1/4, which is not 4. So we can already rule those out. What about the other ones, though? So this is where we have to get kind of creative with our exponent rules. So remember that, well, first of all, this right here, number 5, is exactly our formula, so there's no need to check that. But what about 2 and 3? How can we figure those out? Well, 4 to the power of n minus 1 is equal to 4 to the power of n divided by 4. How do we know that? A to the power of n divided by a to the power of m is equal to a to the power of n minus m. So working backwards on that, this is really an exponent of 1 here. So if we have 4 to the power of n over 4 to the power of 1, you can just do n minus 1. And so we can deduce that this right here, our second choice, is 1/2 times 4 to the power of n times, let's figure this out real quick, this is going to be 4n times 1/4. So times 1/4 over here. Well, 1/2 times 1/4 is 1/8, so we have 1/8 and then times 4 to the power of n. So 1/8, 4 to the power of n. This one does check out. What about number 3? So we're going to do a similar thing here. 4 to the power of n plus 3. Well, similar rule to this over here. A to the power of n times a to the power of m is equal to a to the power of n plus m. So these are two rules that I highly recommend knowing. But we can break apart this 4 to the power of n plus 3 by getting a little bit creative here. We can recognize that this is equal to 8 times 4 to the power of n times 4 to the power of 3. And so 4 to the power of 3 is, see, 4 times 4 is 16. 4 to the third is 64. So we have 8 times 64, which is a big number. It's 512. 512 times 4 to the power of n. This is definitely not this over here. So 3 is not an option. The only two formulas that could represent the sequence are these two right here. And now for the last one, the first term of an arithmetic sequence is 4, and the common difference of the sequence is 3. What is the seventh term of the sequence? Well, if we know that we're dealing with an arithmetic sequence, we know that it's going to be in the form of a sub n is equal to a sub k plus d times n minus k. Well, if we know that the first term is 4, then we could use the fact that we're given that the first term is 4, let k equal 4. This is a sub 1 plus d times n minus 1. So if we know that a sub 1 is equal to 4 and our difference is 3, then we can just plug this information into our sequence or into our formula here. We have a sub 1 or a sub n is equal to 4 plus 3 times n minus 1. And if we want to figure out what the seventh term of the sequence is, then a sub 7 is equal to 4 plus 3 times 7 minus 1. This is equal to 4 plus 3 times 6. And this is equal to 4 plus 18, which is 22. So, and we could even verify that if we, so a sub 7 is equal to 22. We could even verify that if we, this isn't a very long sequence. So if we start with 4, and if we're adding 3 every time, 4 plus 3 is going to be 7, plus 3 is 10, plus 3 is 13, plus 3 is 16, plus 3 is 19, plus 3 is 22, ... And look at that. A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6, A sub 7. A sub 7 is 22. And so we know that our formula works. Anyways, that wraps up this video. This was a lot longer than I thought it would be, but I guess that's how it would be. Anyways, thank you for watching.